Hi, hey, it's Zixuan, and today I'm gonna do a presentation and with live demo for my project on resources and cost analysis of machine learning or deep learning model inference on serverless-based versus serverless-based cloud computing services. And here is the content of today's presentation. The first one is the introduction, whereas in today's world there are many two kinds of model inference-based model, which is the first one is infrastructure as a service, where that the providers can choose the infrastructure they want, like the number of computing resources, like the number of the memory or number of bandwidth, etc. However, there's another kind of event-driven service model, which is called function as a service, where the provider can only provide a handler or lambda function, and then the owning the function will be called when there's a request from the user, and in all other cases, the function will remain idle. And next, I'm going to introduce the method of my experiment, which is mainly through three parts. The first one is prepare dataset and inference model. Here are two datasets I'm going to use. The first one is UCI adult income dataset, which is for regression purpose. And the second one is the breast cancer Wisconsin dataset, which is actually for the classification purpose. And the two inference model that I choose is the first one, XGBoost, which is a relatively advanced machine learning based model, and the MLP, which is a beginner friendly deep learning based model. And next, we're going to do for the experiment is implement the inference function, where the input is just as normal and input array with feature values. However, we change the output a little bit, not just return the predictions, but also including the inference latency for further analysis. And last, we're going to conduct the experiment on AWS EC2 and Lambda separately with different combinations of the datasets, models, and number of requests. And after gathering all of the experiment results, we're going to conduct analysis through three different perspectives. The first one is inference latency performance. The second one is resource usage, and the last one is cost analysis. And next, we're going to do the experiment and show a live demo of it. The first one is the EC2 experiment, and here's the steps we're going to show in the following demo video. Okay, I'm going to do the live demo for the EC2 experiment of my project. And for the first and foremost, we need to create two instances. One is for the server for model inference, and the other is a client that is sending the inference request. And for the system here, we're gonna choose the Ubuntu 22.04 version. And for the instance type, we could just wait a second. For the instance type, we could just stick with the T3 micro. And for the key value pair, you can choose whatever you want or create a new one. I'm gonna choose a project here. And one of the important things is that we need to choose a security group that supports all kinds of like TCP, SSH, or UDP connections. As you can see here, my security group supports all kinds of connections. And finally, we're gonna give like a 30 gigabytes storage to each of the instances. And given that I've already created two instances, so that I'm not gonna create new things here. And let's go back to the Xmobile term here. And I've already created like three terminals. The first one is for running the model inference. The second one is for running the resource logger that is going to record all of the resource usages. And the last one is for sending the request, like sending the client request. And for all of the scripts that is doing the experiment setup and running it, you could see here inside the setup/ec2.sh file, which includes all of the shell commands. And I'm gonna run the experiment here. First is to start the server, and you can see that it's running on this address. And second is to running the resource logger that's gonna do the resource recording. And the last one is to running the client, where you need to notice that this is the public IP address of the server with the 5000 port, and also you need to choose the data that is doing the test and the output accordingly. And I'm gonna run it here. And you can see that it writes 100 rows inside the results.ec2/latency.csv, which with the 0.473 seconds experiment time. And finally, we could like just close the resource logger here, which also gonna write the resources within the experiment inside this CSV file. And finally, we could just simply SCP all of the results back to our local computer. And that's the end of our live demo for the EC2 experiment. Okay, we've seen our EC2 live demo on how to do the experiment on EC2. And also, we're also gonna have a live demo for the Lambda function experiment. And here's like the basic steps for it. And also, we're gonna show the demo for the Lambda function experiment. Okay, now I'm gonna do the live demo for the Lambda function experiment for my project. So firstly, we could create a Lambda function and using the Python 3.11. One of the things that we need to note here is that we need to set the role being the lab role. And this is our basic configurations. And after that, we could pre-upload the lambda/xgb.zip file inside the Amazon S3 bucket. And we could like using this URL to load it inside the Lambda function if your file is a little bit too big. Yeah, as we can see here. It should be successfully loaded. Yeah, it's successfully loaded. And the third thing we're gonna change here is the handler. And given that we're using the handler.py file and having a lambda handler inside, we need to set the handler function being handlers.lambda handler. And then we need to set up some of the configurations. As you can see here, the memory we set here is the default 128 megabytes. And we're gonna set the timer being 3 minutes, given that the inferences actually take some time to do it. And the last thing we're gonna change is the environmental variable. We have one environmental variable here, which is the dataset. We have two choices, which is the adult dataset or cancer dataset. And this is basically the setup for our Lambda function, and it will be all done. And next, we're gonna jump back into here, into our command line. And the first thing that we're gonna do is to set up the AWS CLI access under the /aws.slash/credentials. And we need to copy paste these things inside here for further access to the Lambda function. And as you can see, I've already pre-did it for the sake of time. And after this is done, we could like just look at the experiment/lambda.sh file to run the experiment. And the experiment that we're gonna did is like the project xgb being the Lambda function name and the 10 requests and with the data here and the output here. And the most important thing is the region that we need to set to the region that we currently use. And let's have a try. Given that this is a Lambda function, it probably takes around 1 minute to run the whole process and giving us the feedback. And before like we having the feedback, we could just look at the CloudWatch. Like the CloudWatch, we're gonna gather all the uses from the AWS CloudWatch and how is the usage gonna be and how is the cost gonna be. We can use this command to get all the usage of our Lambda function. And one important things to know here is the start time and end time here being the UTC plus 0. So you need to adjust it to your time zones accordingly. And we're gonna like here we finish our experiment, and we're gonna try to, for example, run the fetch Lambda matrix to see how this is gonna be. Let me have a try. And yeah, given that this is like a random time that we're gonna use, so we don't have anything that is down, but in real time, you could set it accordingly to your use, and you could get the important information and usage information from AWS CloudWatch. And that's all for the Lambda function live demo. And okay, we've finished both of the demos of the experiment, and let's jump right into the conclusion part. And the first one is for the inference latency analysis. As we can see shown in the plot that the EC2 latency most actually around 0.25 milliseconds, with some outliers ranging from 1 millisecond to 2 milliseconds. However, for the Lambda latency, actually most of them is around 1 millisecond, with some outliers due to cold start problem may up to 15 seconds. So Lambda function definitely has weaker latency performance. And for the resource usage, the EC2 resource usage is actually just based on the instance types that you select. And the Lambda usage can simply choosing based on the memory, and the Lambda function will auto-adjust the computing resources based on the actual usage situation. And finally, for the cost analysis, for the experiment cost, we can see that the Lambda actually cost based on the request number, and the EC2 cost based actually mostly on the instance type and the lasting time interval. So that for the right price, you can see we made an estimated cost versus request density plot that shows that Lambda actually more cost efficient when the request density is less than 70K per hour. However, in other cases, the EC2 instances might be more cost efficient. And thanks for your attention. That's all for my presentation live demo.